There's not. Okay? We go over 1 inch and 1 inch. Okay? Here's where things change. Okay? This is just like in your car and your odometer. You drive somewhere, you reset the odometer, you drive somewhere else. You stop, you reset the odometer. Every time you get to a stopping point, you reset the odometer. So we're going to reset our X and Y axes. So the way you got to look at it is, now your origin has followed you. Now in position 1. So now we're just going from here to here. So to go from 1 to 2, it's 1 inch. And X and Y is 0. If you're writing a program, you wouldn't even have to put it there. Okay? From 2 to 3, again, the origin follows you. So it's 1 inch, and it's 0. Now we're there. All right, going from 3 to 4. Now just realize, as the origin followed me, I'm plus, plus, plus. Now I'm going in this direction, aren't I? In our incremental system, it's just like the origin has followed you. So I do got to put a minus to make it go this way. Okay? Let's see, I'm over 3 inches. That's 1.5 inches. So it looks like it's minus 1.5 inches. And Y is plus 1. Making sense so far? Same thing here. Origin has followed me. Okay. I'm there. Now I'm just going to 5. So now I just go to 1 inch. And I don't got 1 over there. And at the very end, I want to backtrack to the origin. So, I mean, I can add up all my numbers and do the opposite. I got 3. I got minus 1.5. Wait a minute here.
4 minus
2.5. Oh yeah, I got minus 2.5. And then I got 1. I got minus 2. Now you should be able to add all these up, and you should come up with 0. Okay, that's the way you would check yourself on an incremental system. Okay. Now, they started coming out with absolute type programming systems in the mid-70s. You think, okay, why would you ever want to think about incremental commands? I mean, it's something of the past. Well, incremental programming commands can save you a lot of time on the machine when you really know the controls, when you know a little bit about manual programming. For example, let's say you got a job and you've got to make 1,000 holes. You've got a whole bunch of little holes you got to make. Okay, all the way down, 1,000. You're on the machine. Yeah, there's Mastercam and SurfCam. That's great. CAM systems do a lot of good things. Okay, but if you're making some tooling, you know, by the time you get up, you're in a big shop. You get off the machine. You go up to the office. Come back. You have to be 45 minutes later by the time you get back down with the program that you just posted. Well, guess what? If you know how to manual program well, this looks like this. You give it line of code to drill a hole. Let's say the first hole was at X of 1 inch. I'll just say Y 1 inch. Here's your depth. I'm going to say just minus ½ inch. I'm making more room for my code. Since I got a GD3, I have a peck depth. I'll just say 200 thousandths per peck. Have to have an R plane. Have to have a feed rate. Got to have decimal points and all this stuff. Decimal points are important. Now the feed rate, for example, you got to have a number there. Let's say you forget your decimal point right there. It's not going to really hurt a whole lot. Okay? But let's see here. There's a ½ inch of travel per hole. That's what the bin is going to peck. So you get a ½ inch of feed for every hole at 10 inches a minute. No, not at 10 inches a minute. You have a feed of 0.001 inches per minute. So how long is it going to take you to drill that ½ inch hole? That deep, ½ inch deep hole?
Until I grow a beard.
Until you grow a beard. It's going to take a long time. Okay. So anyway, so the decimal point, yeah, they're important. So otherwise it won't feed. So, all right, back to my hole. All right, so this would tell it to go to the first hole and drill a hole. But there's 999 more holes to do. That's going to really suck to have to write out 999 different holes, isn't it? Well, if I know how to manual program well, I could say, well, you know, let's kick to a sub-program. I'm just going to make up this goes to program 0100. Let's repeat that program 999 times. And then when it sees program 0100 in the control, what you're going to have in there is a G91. Incremental, right? You're going to tell the spacing in between each of your holes. Let's say it was 1 inch. I know there's not too many thousand travel machines out there, but there are a few. You just give it the spacing. That's it. You're done. Into subprogram right there. There, I just drilled 1,000 holes. Just lickety split. If you know a little bit about manual programming, you don't need to be a master at it. Okay, and just realize that, you know, the cam systems, whether you use a mass cam, surf cam, spree, whatever you got, you know, you need it. Okay, you're not going to manual program out of, you know, most of the parts out there. But for doing some basic tooling, you know, I can even make a program that machines a little slot. I can come in here and make it all incremental, do an incremental shift, and just copy it, repeat it. Okay. All sorts of little tricks you can do knowing how to use incremental programming methods with the subprogram calls, the copy commands, and stuff like that. Okay. So there's a lot of value to knowing a bit about manual programming, at least knowing the basics. Okay. And where you can use incremental to your advantage. All right, you'll see an example of this probably in 115 class a little later on the semester, because I would always do it, and Brian would always do it too. A couple of good incremental programming techniques, so you'll get a chance to see that when you understand it a little bit more at that point. All right, so does that make sense to you guys? Very important to understand the difference between those two. Wow, I'm a little bit ahead of the morning class. Did I skip something?
Nope. We had our GECO quiz. You talked about...
Talk about it more efficiently.
I skipped something important.
Did I skip something important? That's right, I never know. Well, that's why I take pictures of the board in the morning, just so I make sure I cover everything I want to cover at night. And I keep the classes consistent. The only thing I didn't talk about was what happens when you have an error in incremental programming systems. Let's say this was our B-52 bomber wing. I know it's only got 5 holes, but let's say it's got like 1,000 holes. Okay, and let's say we didn't bother to do this. We were in a hurry. Okay, so we made our airplane wing. We drilled our 1,000 rivet holes overhead. All incremental, because it's all, you know, this was 60 years ago, that's all we had. Okay, machine got all done, we programmed, we backtracked it to a starting point to start the next wing. Let's say there was an error in there, 30 thousandths of X and 30 thousandths of Y. Okay, that's kind of a dangerous error on a part like that that probably has a pretty wide tolerance zone. That's probably like plus and minus 1/8 inch tolerance. Okay, because the problem with that is, when it does the next wing, it'll do it, and it'll be good. But everything will be off exactly 30 thousandths in X and 30 thousandths in Y, which would probably meet quality control standards, probably would pass if it's plus and minus 1/8 of an inch. And so the guys running the shop floor will probably say, oh yeah, it's a good part, throw the next one on. So they'll throw the next wing on. And because what's going to happen is you have an accumulation of air. The next one's going to be 30 thousandths on top of that for a total of 60 thousandths off the original. Okay, and then again, it's going to be an accumulation in air until you're just plain making bad parts. Okay, so that's why it's very important in incremental systems, always add up your numbers. If you have an error there, it will show you. Okay? Now, for what you guys are doing, you know, we're going to be visually looking at, eyeballing, checking out the lines. If you add up those numbers, they are going to be off a little bit, unless you add up your numbers and use that for your last points. But anyway. All right, so let me give you the located practice.